All right, so we're going to start with your combination reaction. Obtain a piece of magnesium metal ribbon and make an observation. So here is your magnesium metal ribbon, all right? And your observation would be that it's shiny, it's hard, it's solid, right? Silver, that is your magnesium metal ribbon. Then hold the ribbon with crucible tongs into the flame until it is ignited. All right, so we want to find the hottest part of our flame, which we know is the tip of that inside flame. All right, so that was our reaction. Describe your product. So if we look, if I tapped it on the table, it all crushes up. It's now white, powdery, it's gone, all right? It's been burnt, it's down to ashes. And so you're gonna write the complete balanced equation for this reaction. Knowing that you burn it and that you started with magnesium metal should help you come up with that. Next, in a medium dry test tube, you are going to place a pea-sized sample of solid ammonium carbonate into the bottom. So here we have our solid ammonium carbonate, and hold it with the solid at an angle in a low flame and heat gently. Record our observations if it has an odor, all right? So you should have wafted it to know that it has a pretty pungent odor, all right? And it's dry, and then when we put it into our flame, it says moisten a piece of litmus paper, which you don't really have to moisten it for it to work. So I've got my litmus paper here. And heat this up, let it start. See how it's starting to boil? This one did have a little bit of water down in there, all right? So that's part of the reason why it's boiling like that. And put it into your test tube. So you can see the tip of my litmus paper is now blue, all right? When I put it in here, it's blue. It started out as a reddish pink, and now it turned blue when I put it into my test tube. So what product is identified by my litmus paper? Look at your notes and things you wrote down from the board. Remember, litmus paper turns blue in the presence of a base and red in the presence of an acid. So we talked about what base might have potentially been produced, all right? Then the next thing you were to do is, with this heated, light your wooden splint, all right, and stick it into the top of your test tube. All right, notice that our flame went out. So what does that indicate was being produced by our reaction when it decomposed? We can also look, and I noticed that I have some condensation in my test tube. That tells you another one of your products that was produced. All right, write that balanced equation. So I had ammonium carbonate and I decomposed it. Moving on to your single replacement reaction. You have a few pieces of zinc metal in a test tube. And you are going to add hydrochloric acid. So here is my zinc metal and here is my hydrochloric acid. And I'm going to add it until it's about halfway full. All right, and let it start to react. I'm gonna put a stopper on the top to help hold in that gas. All right, as the gas is produced, the stopper may be popped off. That's totally fine. We want that to happen. I'm gonna bring it close so hopefully you can hear. So I'm going to build up the gas with my thumb. We're going to let it build up some pressure so that we've got a buildup of gas within our test tube, and we can test that gas that's being produced. All right. I'm not sure if you could hear that well on the laptop, but I let a big whoosh, like a big gust of air, Or sometimes if you get a lot build up, it'll squeal or pop, all right? Some people say it sounds like a bark, all right? But there's a little whoosh when I put that flame in, all right? Notice it didn't initially go out until I put it all the way in and I took away all the oxygen. So it wasn't a gas that put the flame out, it was a gas that made it go whoosh or bark, squeal, etc., depending on what you hear that sound as. All right, next we have our double replacement reactions. So I'm gonna go ahead and get my test tubes prepared for that. And it says to put about 10 drops of lead nitrate in a medium test tube. So we're gonna find our lead nitrate. Lead nitrate, we've got PbNO3. Pb is our lead. All right, and so here's the test tube I'm gonna start with. And I've got 1, 2, 3. There we go. There's our lead nitrate. Then I'm gonna add my potassium iodide. Here it is, Ki, potassium iodide. And I'm gonna add it in equal parts here. So here's my lead nitrate, and here goes my potassium iodide in it. Look at the change that you see in that substance. So you've got kind of a chalky yellow, all right? It's chalky, you've got the formation of a precipitate. If I let this settle, there'd be like a white or yellow powder down at the bottom and some liquid, and you see a color change. Those things indicate that you're having a chemical reaction, all right? So that was letter A underneath of double replacement reaction. Record your results and write the balanced equation. Now we're gonna repeat it with lead nitrate and hydrochloric acid. So again, here's our lead nitrate, there's your formula, all right? And in my new clean test tube, I'm gonna put 10 drops, all right? And then hydrochloric acid, HCl. All right, equal parts. So on these two, I combined them together. They started out as clear substances, and now, if you can see, I have some white precipitate down at the bottom. Somebody said, oh, it looks like the stuff you make fake snow with, all right? So, again, this is your lead 2 nitrate and hydrochloric acid combined together, all right? That lets you know a reaction occurred because not only did you have the formation of a precipitate, but there was a color change. It went from clear to white. And lastly, repeat with solutions of copper 2 sulfate and sodium hydroxide. So, copper 2 sulfate, here is our copper 2 sulfate, and sodium hydroxide. So let's go ahead and put this in. Sodium, Na, hydroxide, OH, equal parts. And here you see what that combination looks like. It went from this really faint blue, right, diluted blue, to a really dark and vibrant blue. And it's kind of got like a gel-like substance in it, all right? If you look, it's kind of chunky. You can see some chunks around the side. So, lets you know your chemical reaction has occurred. That again is your copper 2 sulfate and your sodium hydroxide, right? That is your double replacement reactions. And then flipping over and going to combustion reaction. Place about 10 drops of ethanol in an evaporating dish. All right, so here's my evaporating dish. And we are going to light it on fire. So let me go ahead and get this prepared. Turn our Bunsen burner back on. I'm gonna use our splint to light it. All right, we've got our ethanol in our evaporating dish, and it's kind of hard to see, but there's a fire going in that alcohol. All right, so we're gonna take a clean, dry test tube. Making sure you all can see that. Yep, you can see it, awesome. And we're gonna turn it upside down over that. Now this one happened pretty quick, and it's gone away, but what do you notice on the sides of this tube? It happens initially, and then it's then dried off and evaporated away. But you notice what? Condensation on our test tube. So that is your combustion reaction. That condensation shows you that water is being produced. All right, once our test tube heats up, it's no longer cool enough to take that water and turn it back to a liquid. So it is now just continuing to evaporate. But you are seeing your combustion reaction of ethanol. All right, so that's what you should have done for your lab. Those are the things you should have walked through for it to get your information. We're just going to let this burn off. Ethanol will just continue to burn until the entire substance has combusted. All right, if you have any questions, let me know. Email me, send me a comment on the video, and I will help get you situated.